Okay, in this video I'm going to talk to you about two methods for evaluating limits. The two methods we're going to talk about today are numerical, which involves creating a table of values, and graphical, which means we just create a graph and we analyze it. So let's talk about a particular limit, and we're going to look at the limit as x approaches 1 of the function x cubed minus 1 over x minus 1, and of course x cannot be equal to 1. So if you look at this, you might see a little bit of a problem. We want to know what's happening to this function from the left and from the right of 1, but if you'll notice at 1 we have an issue. We have a divide by 0. So this is a very good illustration of how limits are not about looking at what's happening at an exact moment in time, but instead at a specific area. So let's take a look. We're going to go ahead and create a table. And hopefully I can set this up neatly enough on here because I'm just learning to use this software a little bit. And we're going to look at x and f of x. And we're just going to plug in values arbitrarily close to 1 because we know at 1 this function is undefined. So let's plug in, I don't know, 4 or so on this side, and maybe we can get 3 or 4 in on this side. Alright, so to the left of 1, I know that the number 0.999 is really close to 1. And 0.99 is also close, but not quite as close. And 0.9, and then sometimes we kind of drop down a little bit. So if we plug these values in coming up to 1, and then on the other side of 1 coming from the other way, if we were to look at 1.001, very close to 1, but still not 1, 1.01, 1.1, and 1.25, now we're still close to 1, but we're moving away from it. If we were to, and we won't do the math here, but if I'm to plug these values in, here I'm going to get 2.313, and here I'm going to get 2.7 something, here I'm going to get 2.970, and then at 0.99 I get 2.997. So as you see, as we're going to the right, we're getting really close to 3. So what we want to see is coming up from this, or from the left, I'm sorry, and coming up from the right, we want to see the same behavior. This is how we know a limit exists and what that limit is. So at 1.001, if I plug that into this formula, I get 3.003. 1.01 is 3.030, something like that. 1.1 is 3.31. And 1.25 moves away at 3.8. So as you can see, we're getting closer and closer and closer to 3 from either side, either coming in from the right or coming in from the left. So analyzing this by a table, we can see that the limit of this function as it approaches 1 is 3. So if we were to draw the graph of this, hopefully I can put a little bit of a graph off to the side here that you can see. The graph of this thing, and I'm sorry, the software makes it kind of hard, says that at 1, as x approaches 1 here, the value of the function is getting closer and closer to 3. If you were to graph this, you would see it looks something like this. But what happens here, because it's undefined at 1, is there's a hole in the graph. Regardless, the behavior of the function coming up to 1 and coming from the right of 1 still is approaching 3, even though there's an actual hole at 3. Hope that makes sense for the table method. Now let's move on and find some information about the graphical method. You kind of saw a little bit of the graphical method there by analyzing that. But there's also one where a limit fails to exist. So the limit will fail to exist when the values to the left and right are different. If we look at something like the limit as x approaches 0 of the absolute value of x over x, if we were to look at this graphically, over here I have some values to the left. So if I were to plug in, say, -1, -1 gives me 1 over -1. So these end up being negative numbers on the left because this will always cancel out. So what it ends up looking like is I have a hole here at -1, and it's a line coming up. And then if I were to plug in positive numbers like 1, absolute value of 1 over 1 is just 1, I'm going to find that it's going to look like this to the right. So I end up with a number over its number. It's either going to be positive or it's going to be negative. So as you can see here, as we're coming up to 0 from either direction, we're approaching a different value. From the right, we're approaching 1, and from the left, we're approaching -1. So these are indicators that the limit of this does not exist. So here's the one I want you to do for class. So we're going to look at oscillating behavior. So your example for class I want you to give a shot at is to use a table and a graph. I don't care what graphing utility you use. I have graphing calculators in the classroom if we need them. To determine if the limit as x approaches 0 of the sine 1 over x exists. So that is your practice one to discuss and talk about, and we'll talk about it in class. See you later.